All right, this is our game. Let's see what it did. This chapter name is AI generated. So prologue, the shadows gather. The system kind of created this, all these characters, the chapter. So let's kind of go into all the different things that it did. In this scene, it also chose the music that's playing in the background, and it scripted this entire conversation. So here we are in our prologue chapter. This is a demo of what I'm calling FE Infinity. It's a system that uses AI to create a brand new, unique Fire Emblem Game Boy Advance game. So let's go ahead and create a new game. We'll run the script. So under the hood, we've got our static game engine that has all the game rules, how the battles are calculated, everything like that. And the AI system is creating a game object that can be passed into the game engine, and it'll tell the game engine all the text, the storyline, the character portraits, the music choices. And so essentially this AI is creating this kind of game object that can be consumed by the engine, and it will create a Game Boy Advance file that can be played in a GBA emulator. So let's go ahead and wait for this to finish. All right, now it is done. Looks like the AI took 104 seconds to create this game. So the game is 3 chapters, so like 3 full levels, and each chapter includes a pre-battle kind of conversation with the characters, then the battle with the map and all the units, and then a post-battle conversation with the characters kind of talking about the aftermath. So 3 chapters were made in just over 100 seconds. Here we've outputted this kind of game object that I talked about before. It's got, our character with their stats. It's got a bunch of, our character's backstory. It also has our chapters that have, their maps and what to, what text to show in the conversations and everything. So let's go ahead and run this. All right, so this is the kind of engine, the game engine that's taking in that object that I just showed you, and it is building the .gba file that we're going to be able to play in our emulator. So this takes about 20 seconds. All right, this is our game. Let's see what it did. I'll start a new game. And again, all of this UI and everything was not generated by the AI. This is part of the game engine that we don't have to touch. However, this chapter name is AI generated. So prologue, the shadows gather. And the system kind of created this, all these characters, the chapter. So let's kind of go into all the different things that it did. So first, it came up with this idea for the chapter and the main character. And from a set of portrait options, so we've got like our character faces. The AI did not generate those from scratch, but it took a huge list of existing character portraits, and based on the character idea and kind of feel of the character, it shows which portrait matches the closest. So in this scene, it also chose the music that's playing in the background, and it scripted this entire conversation. So we've got Nithoria. Have you noticed the shadows lurking around the village? She says, yes, Eldon, it feels as if something dark, blah, blah, blah. So I'm going to skip this. It's, this is kind of setting up our storyline and everything, but we don't have to go into it too much. So I'm going to go ahead and skip. And so here we are in our prologue chapter. So this map was not AI generated, but similar to the character portraits, based on kind of the chapter and the battle overview of what the AI came up with, it will then choose from a long list of existing maps and kind of use that to work with. I found that it was really hard to make an AI create good maps, so for now it's just choosing from ones that we already know are good. So let's take a look. We've got our two characters that were in the prologue, or sorry, the conversation before. Each of them have, description and stats. So Eldon is a charming warrior. Nethoria is a determined young woman wielding ancient magic with a troubled past. So these kind of descriptions and character classes and everything, as well as the starting inventory, was all chosen by the AI. We also have this kind of green unit, which we'll be able to recruit. So they also have a description and a starting inventory, and let's see, all the enemies, the AI kind of took the chapter story into account and decided, the boss is going to be this shaman, ruthless leader of the Veil of Night. So that's kind of like part of this story arc that the AI came up with. The Veil is this, secret organization trying to do evil, something like that. And so it kind of decided, okay, the boss should be in front of this door, because that seems like, defensible. And it decided all of the enemy units and their placement. So it also decided their starting inventory. An archer would start with a bow, a knight would start with a lance, etc. One thing that the AI is actually a little weak on is the unit placement. Like, this is maybe fine for a first chapter in the game, but it doesn't, right now, I found it a little difficult to program to think strategically with kind of this spatial data and say like, oh, we want, this kind of unit here because that will map to how the player will need to strategize. So it doesn't do that super well, but it does it good enough for now. Alright, so let's recruit this new character. So again, the AI came up with this whole recruitment conversation. It also came up with our new character, which is this healer, and that it decided that they would be in the storyline, that they would start as a green unit, which is like a non-enemy NPC, and that our units would be able to talk to them and have them join the team. So again, it scripted this entire conversation. It chose the music to play in the background, and I'll just go ahead and skip the rest of it. Alright, so our green unit turned blue. And let's go ahead and use her to visit this house. So the AI came up with the text that this old lady is telling us. This is in line with the rest of the story. This Veil of the Night is kind of our main antagonist, it seems like. And so they're trying to ruin our village with their corrupted creatures. Please take this tome. It holds powerful knowledge that may aid in battle, etc. And so it gave us this item. And so the AI chose all of that. It chose the item to give. It knew that this house location is where it wanted to do that. And it also decided the text to put into that too. So let's keep on playing. And again, these battle animations and everything like that is not created by the AI. That is part of the normal kind of game engine for this Fire Emblem Game Boy Advance game. And all we're doing is we're deciding which characters, which items, which battlefields, the storylines, and stuff like that. Alright, this is not looking good for a new character. And she just died. So here, every character also has their own death quote that gets generated. Balance of life must be restored. Do not let it fade. So she's a healer. Kind of makes sense that she would say something like that. And let's keep going. Alright, so I've defeated all the enemy units except for the boss. And I could go into these villages and they'd give me an item, unique item, and it would be scripted by the AI. Let's go ahead and go into this armory and see what it's got. So the AI decided, based on the chapter, which items should be in this armory. And let's go ahead and go down to this shop and see what the AI chose for that. Alright. Kind of makes sense. Maybe some of the items are a little out of place given this is the first chapter in the entire game. But hey, that's always room for improvement for these systems especially. Alright, let's approach the boss. Okay, so in this system, it creates a conversation for every pair between your player characters and the boss. So going along with the storyline, it will script kind of a battle conversation with the boss for every character. So our character is saying, Zale, your quest for power will only lead to destruction. And then they talk back, and they call out the character by name. So I'll go ahead and skip this. Alright, let's finish him off. Alright, and the AI also chose a death quote for this boss. You cannot stop what is destined to rise. Alright, and now that the boss and all the other enemies are defeated, we have now finished the chapter. We moved on to the conversation after the chapter. So the AI, knew that you recruited this new character on the left, Mira, and it wrote in, with Mira joining us, we have a chance to uncover blah blah blah. And so these characters kind of talk about what happened after the battle, and the story gives way for the next chapter. So I'm going to go ahead and skip this. And we'll save. Chapter 1, Beneath the Veil. So I guess we're continuing on with this Veil evil group. And we start the next chapter with the kind of pre-chapter conversation. And so it'll continue following the storyline, and we've got 3 full chapters, but for brevity's sake, I'll just go ahead and stop the demo right there. Alright, let's get into an architectural overview of FE Infinity. So first we have our AI workflow that runs through all of its steps to create a game object, which is essentially just a JSON object. And that contains all the info needed to create this new game. It has the chapters, which are the levels that include their maps, enemy units, storyline. It also has its characters, which include the portraits and stats and starting inventories. So the game object then gets passed to the ROM builder. So ROM, R-O-M, it's just the name of the Game Boy Advance game file. And the ROM builder takes the game object and creates the configuration files that the game engine can consume. and it uses that to create the playable game. The AI flow and building the ROM are decoupled, so you could change the way the game engine works or even switch to a different game engine, and you would not need to make changes in the AI flow because the ROM builder will always accept this game object. Since the game engine is for a Game Boy Advance game, I'm not going to go into the inner workings of that. It's just implementation details on how to create the GBA game. It's more important to explain how we create the game object itself. So let's dive into the AI flow. So given a world idea, which is kind of a one sentence general direction of the type of world, and the number of chapters to generate, we first create a world summary, which is a description of the world game that it's set in, including geographical regions, nations, factions, cultures. And this data is used in almost every decision the AI makes to ensure the game adheres to one cohesive world. And this kind of mirrors how some games and books are created. The creator first comes up with the lore and the history of the world that the story is set in. Then it carves out one small piece of that narrative for the main character's journey. So next we will generate the story arc, and it uses the world summary and the number of chapters to create a general idea of the main character and how the story progresses in each level of the game. And it only includes high-level details like character names, descriptions, story points, and an overview of the chapter's battle. But it's best to keep this step at a high level so it can later be broken apart into multiple tasks for the AI calls to create the details. So now that we have our story arc, we can run a lot of calls in parallel to flesh out the story and its characters. So here we got chapter 1, chapter 2, and we'll kind of do this whole thing for every chapter. And to be fast, we can run them in parallel because we already have the ideas of the chapters. So technically, these kind of more fine-grained details don't need to be known across the different chapters. That's why we can generate them at the same time. Within generating each character, see we've got a chapter and the new characters that are introduced, which we can also run in parallel. We will have the AI choose from a list of portraits. We'll have it decide the stats for the character, and we will have it create a starting inventory that makes sense for the character and their place in the story and how they come to join the team. Then we'll generate the details of the chapter itself. So first we'll choose a map out of a bunch of existing maps, and then it'll decide the enemy placement based on the battle idea that was decided in the story arc. It will create the battle quotes between our characters and script the pre and post battle scenes. So those are when our characters are talking to each other before and after the battle. And it'll do some more things that I won't get into. And then it will output this game object that we can then feed into the part of our application that will build a playable .gba file. All right, so let's review this system. First, we'll talk about the strengths. Number one, surprisingly, it works. It's not as good as a human making their own ROM hack, but it makes an original 3-chapter Fire Emblem game in 100 seconds, which is pretty cool. It's really good, and this is LLMs in general, really good at story ideas, making characters, choosing portraits for those characters, and scripting conversations between the characters that fit within the story idea. And this system can be split into multiple tools to assist people in ROM hacking instead of making its own game in one shot. Next, the weaknesses. The quality is nowhere near our community's best ROM hacks that were made by humans. Large language models, even multimodal ones like GPT-4o, somehow struggle with making sense of a chapter's map, which results in subpar unit placement. So, deciding where the enemies are in the map, deciding where the players start, where the boss starts, to kind of make for a good strategy game. The language model right now is not great. I can see some kind of low hanging fruit to improve it, but in the first round, it's just okay. Also, it's not able to handle complex game mechanics like creating game code to check for flags such as character deaths across chapters. You might have seen, our healer died when we were playing through the chapter, but then they came back and acted like they weren't dead in the conversation following the battle. This is, typical of Fire Emblem games where, characters die, but they're just kind of too hurt to battle. I think it would be better to, just because the AI could do this more quickly than a human could, to make a bunch of these kind of if checks and change the story based on that. But, right now it doesn't do that. And finally, this is an early prototype. It works okay. It doesn't work great. There's a lot of low-hanging fruit that could easily be implemented to up the quality of these generated games, though. So it's an early prototype, and I think it's fairly promising. Next, we'll go into the use cases. So someone could use a system like this as a solo player who wants to use it to generate a game just for them. And it could be to explore the world of their favorite anime, book, or other game. Or it could be for ROM hackers that want to quickly get to a working starting point and manually tweak from there. So next, one thing that I'm curious what direction the Fire Emblem hacking community would want to take something like this. Would you rather have a game that generates as you play it? So it's an individual game system that will generate the next chapter after you finish one, based on the decisions made in the story, the objectives you're able to achieve in battle, things like that. That's not like what it currently is. Currently, it just generates a whole game at once. Or would you rather have kind of a platform of tools to help assist ROM hackers in creating their own games? So this might take out the work that you would not really enjoy doing, and allow ROM hackers to more easily bring their visions to life. All right, just to close out this demo, I want to reiterate that this is just an experiment. It's not ready to create full games or good games or assist ROM hackers in making their games, but it's a starting point. It's an interesting starting point that could be useful if it was continued to be worked on. So my question for you is, would a better version of this even be useful? And if so, what would you use it for? And I'm also curious your stance on generative AI in gaming. Do you like it? Do you dislike it? Do you like it in certain situations but not in others? I'm curious to hear everyone's opinions. And finally, if you're interested in me making a game for you with this system, send me a 1-sentence description of the game that you want, and I will generate it and send it to you. Well, thanks for sticking with me, and I appreciate the time.